Welcome to my channel. I am Rosan Elginhawa from IT 2103. So, from this activity, which is activity switch it, from the instruction, determine how the switch forwards a frame based on the source MAC and destination MAC addresses and information in the switch MAC table. Answer the question below using the information provided. So, from the table of frame, we have an OA from destination MAC and OC from the source MAC. So, from the MAC table, we have an OA from FA1 and OA from FA9. So, first, we have to answer the question number 1, which is, the question is, where will the switch forward the frame? And from the question 2, which is, when the switch forwards the frame, which statements are true? So first we have to answer the question number 1, which is, for me the answer is this. Then from the question number 2, based on the table and from the problem or the given that give from the activity, I think its switch adds the source MAC address to the MAC table. And the last one is, the frame is a unicast frame and will be sent to specific port only. So that's it. Then the next one, I will explain to you what is the meaning of frame. So what is frame? Any frame less than 64 bytes in length is considered as a collision fragment or run frame, and is automatically discussed by receiving stations. Frames with more than 1,500 bytes of data are considered jumbo or baby giant frames. If the size of a transmitted frame is less than the minimum of greater than the maximum, the receiving device of drops the frame. Drop frames are likely to be the results of collision of other unwanted signals and are therefore considered invalid from the frame fields. We have and then from the given table, which is preamble. Preamble is the start frame. The diameter fields that so the preamble have 7 bytes and start frame. The limiter of the SFD, also called as the start of frame. So fields are used for synchronization between the sending and receiving devices. These first 8 bytes of the frame are used to get the attention of the receiving nodes. Essentially, the first few bytes tell the reviews to get ready to receive a new frame, and from the second ones, which is destination MAC address fields. This is a 6-byte field, is the identifier for the intended recipient. As you will recall, this address is used by layer 2 to assist devices in determining if a frame as addressed to them. The address in the frame is compared to the MAC address in the device. Is there is a match the device accepts, the frame can be unicast, multicast, or broadcast address. The next one is the source MAC address field, who has as 6-byte fields identifiers. The frames originating in IC or interface must be a unicast address. Then the either type that has 2-byte field identifiers, the upper layer protocol encapsulated in the Ethernet. So from the frame, common values are in hexadecimal or 0 times 804 IPv4 and OX 8604 IPv6 and 0 times 864 ARP or ARP. Then the data or the data field. These fields consist of 46 to 1500 bytes. Contains the encapsulated data from a higher layer, which is generic layer. So the PDU are more commonly on IPv4 packet. All frames must be at least 64 bits long. If a small packet is encapsulated, additional data called a pod are used to increase the size of the frame in this minimum size. And then the FCS or the frame check sequence field. The frame check sequence or FCS field have a 4 bytes. It is used to detect the errors in a frame, and it also uses a cyclic redundancy or CRC. The sending device includes the results of a CRC in the FCS field of the frame. The receiving device receives the frames and generates a CRC to look for errors. If the calculation match has no error occurred. So from the calculations that do not match are in that the data has changed. Therefore, the frame is dropped. A change in the data could be the result of a disruption of electrical signals that represents the bits. So from the more address value is a direct result of IEEE enforced rules to ensure globally unique address for each Ethernet device. The rules established by IEEE requires a vendor that sells Ethernet device to register with IEEE. The IEEE origins the vendor of 3 bits or consists of 24-bit code called the Originality of Unique Identifier or COUI. So, from the switch fundamentals, a layer 2 Ethernet switch uses MAC address to make a forwarding decision. It is completely unaware of the protocol being carried in the data portion of the frame, such as an IPv4 packet. The switch makes its forwarding decision based only on the layer 2 Ethernet MAC addresses. So the MAC address table is sometimes referred to a content addressable memory or COM table, while the form COM table, formerly common for the purposes of this course, we will refer to it is a MAC address table. And also from the filtering frames. As a switch receives the frame from different devices, it is able to populate its MAC address table by examining the source of MAC address of every frame. When the switch MAC is address table contains the destination MAC address, it is able to filter the frame and forward out a single port. So from this, MAC address is a unicast address. The switch will not form much between the destination MAC address of the frame and in entry its MAC address table. So if it is a destination MAC address is in the table, it will forward the frame out the specified port. So the next is if the destination MAC address is not in the table, the switch will forward the frame out all ports except the incoming port. This is known as unknown unicast as shown in figure 2. The switch does not have the destination MAC address in the table for PCD, so it sends the frame out all ports except for port 1. If the destination MAC address is a broadcast or a multicast, the frame is also flooded out all ports and incoming ports. So from this activity, that's all I have learned. So thank you for watching.